Hello, 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 check.
Good mo- good morning. Hello, hello. It is still not audible. अरे सुनाई नहीं. Good morning, distinguished guests and respected colleagues and esteemed participants. It is my honor to welcome you all to this plenary session on climate smart agriculture innovation and adoption for sustainability. Agriculture lies at the heart of our societies, feeding billions and sustaining livelihoods. Yet, it is also at the front line of challenges posed by climate change. Today, we are tasked with not just discussing these challenges, but innovating and adopting sustainable solutions that ensure resilience, equity, and long-term productivity. This session brings together brilliant minds from across disciplines to explore innovative approaches, share insights, and drive the adoption of practices that align with both environmental sustainability and food security. Together, let us work towards a future where agriculture thrives in harmony with our planet. With this, I officially declare this session open and invite our esteemed panelists to lead us into the discussion. Let us make this platform for actionable solutions and meaningful collaboration. As a panelist, today we have Dr. Markandeya Gorantla, Managing Director, ATGC Biotech Private Limited, LSI IKP Knowledge Park, Genome Valley, Hyderabad, AP, India. We have Professor Gautam Saha, former BCKV, Dr. Madhumita Mitra Sarkar, Professor Floriculture, Faculty of Horticulture, BCKV, West Bengal. Dr. Amit Baran Sharangi, Professor and former Dean Faculty of Horticulture, BCKV, West Bengal. Professor Pravat Kumar Sarangi, former Professor and Head Department of Entomology, College of Agriculture, OUA, BBSR, and Professor SOADUE Bhuvaneshwar. Dr. Shankar Kumar Acharya, Professor, Department of Agricultural Extension, Faculty of Agriculture, former Dean, PG Studies, former Director, Dr. Anshuman Jaina, Associate Professor, Agricultural Extension, Institute of Agricultural Sciences, SOU University, Bhubaneswar, Odisha. We have with us Dr. Pramod Kumar Raut, Principal Scientist, ADG ICAR, Dr. Joe K. Kizakadan, Principal Scientist and SIC Regional Center, ICAR, CMFRI, Vizag. And with us we have Dr. Sagar Maitra sir, the Dean of MSSOA. I would like to request all our esteemed delegates to kindly come on stage and take their seats. Your presence here signifies the importance of this session, and we are honored to have such distinguished individuals with us today. So please. মার্কেন্ডিয়া স্যার রাইট উনি প্রথমে স্পিচ দেবেন ওকে ফেলিসিটেট করবে তো ডক্টর সাগর তারপর স্যার দেবে হ্যাঁ সাগর মেহতা স্যার যদি আসছে ওনারা আসুক কাকে দিয়ে করাবো ফেলিসিটেট So today our chief guest is Dr. Gorantla, who is the Chief Executive Chairman of ATGC Biotech Private Limited and co-founder of IACA Incorporation USA. So I will request our VC ma'am to kindly felicitate Dr. Gorantla. So with a PhD from the University of Hyderabad, Dr. Gorantla has identified over 3,000 genes in rice and pearl millet for gene bank and developed cutting-edge pest control technologies. A serial entrepreneur, he also works on cancer therapeutic and has led award-winning programs with global organizations like DST, DBT, BIRAC, and USAID, revolutionizing sustainable agriculture and pest management. I would request Dr. Goranla to please deliver us with a speech, please.
Yeah, thank you. It's a great honor to be participating as chief guest here. So I'm Dr. Markandeya. We work in area-wide management of insect epidemics around the world. So the future of sustainable regenerative agriculture is focusing on something where a biotechnology can play a very key role in addressing the crisis. So we have the current crisis is climate change. So the climate change. Yeah, no problem. How to change the slides? Yeah. So going forward, I think synthetic biology will play a very key role. I'm also expert member for many of the committees of Indo-US for sustainable agriculture. The Bio-E3 policy document on sustainable agriculture I was part of the committee which drafted the key policy. So what is Bio-3 is all about? It's all about biomanufacturing scale up where biotechnology can really make a big impact. In India, we are very far ahead in terms of contributing to the GDP in terms of biotechnology. In US, almost one fourth is contributed by biotechnology. In India, it's not even 1%. So there is a tremendous opportunity to leverage our expertise to scale up biotechnology, especially in agribiologicals. We have a lot more to do. Just to say about few of the products globally, one product sells. What is a product? A product is derived from an innovation from biotech, using biotech tools, or it can be a new small molecule. So either one of them, the development takes a very long time. It takes normally 8 to 12 years and costs billions of dollars. So those are the products, but in agribiologicals, the good thing is that we can develop it with hardly $2 to $5 million. So that's the interesting part, how we can use such a less amount to launch a product. A product is something which can sell minimum $100 million, which is basically about 1,000 plus crores. If it's not, that's not a product which we need to even think of it. So that should be the basic impact in the market. So a lot of changes in the policy today. We have the National Research Foundation coming up, a Bio-3 policy under which more than 10,000 crores have been allocated for biotech sector, just specifically focusing on climate change and resilient agriculture. So what we do, so we are basically a research and development company. We are based out of Israel and US and India in the Genome Valley. What we do is we figured out a way to protect crops by modifying the behavior of insects. So you see a male ping worm landing on my nail, a fingernail. So the outcome of this particular slide is, what we need to understand is this particular chemistry of chemochemicals, they are very, very sensitive. They are active in picomoles. That's the reason why they can be very impactful in terms of how they can contribute to crop protection. So technically, it takes 1 or 2 kilograms of any insecticide to manage 1 acre of a field to control any pest. Here, with chemochemicals, by modifying the behavior of insect, we can completely control the pest with just 1 gram of the chemistry. And this 1 gram of the chemistry of chemochemicals is natural in nature. So these are basically, chemochemicals are nothing but which are emitted by insects, by flowers, by various species in nature. So how to harness this information and manage the behavior of an insect to protect your crops is all about resilient and regenerative agriculture. Yeah. So the way we approach it today, we are the largest company in the world to have developed products using this particular chemistry, chemochemicals. And people are talking about sustainability. So what is the key issue in the next 10 years? What is that going to happen? So we have a real crisis. Climate change is being leading with every 1 degree increase in temperature. The breeding cycle of insects have been really, really increasing. Instead of 2 or 3 cycles, they are now breeding for more than 5 cycles. Their net reproductive rate is so much increasing that we are not able to manage. So that's the reason why you see epidemics, insect epidemics like locust. So we basically address worldwide insect epidemics. All such locust kind of insect epidemics where there is sudden breeding of insects is what we address. So going forward with the current crop protection tools, what we are using, they are all dependent on fossil fuels. So each of the formulations, whatever we see, they are derived from fossil fuels. So they don't last for more than next 10 years. So if they don't last for more than 10 years, so what is the next? So synthetic biology is the key. The synthetic biology, with the way how nature produces bioactive molecules, if we focus there by unlocking the biosynthetic pathway by strain engineering or producing the pheromone biosimilars, to synthetic biology, that will be the key for next 10 years to take care of our future generations. It should be net zero. So today we are very, very far ahead of even carbon neutral in terms of crop protection tools. We use fossil fuels for formulation, we use 2 to 3 kilos of chemistry. That's not at all sustainable. And every molecule today is resistant to insects. So what is it? And to develop any new molecule takes billions of dollars and at least 10, 15 years to launch a new molecule. And where India can really focus is on biologicals, and this is where the strain engineering, the agri-biologicals, where biotech intervention can be done. So those are the areas of focus. So baculoviruses, strain engineering, secondary metabolites, synthetic biology is the next 10 years future for all of you to work on. And CRISPR really will help you to develop products with the kind of biodiversity what exists in nature today in India. We can unravel the biosynthetic pathway of these particular microbes which produce different metabolites which can be used for various purposes in life. So there is no funding agency which has not funded us. So more than $40 million to 300 crores we have got in grants to develop this particular products using chemicals. This is the example what I will say. So how do you manage, change the behavior of an insect? So everybody knows fruit fly you can attract by, by using attractants. But how do you modify its behavior? Can you make it, how do you tame it? How do you control it? Is what is the chemistry. So this particular semi-chemical which we formulated is basically contains three different semi-chemicals: an attractant, a foraging pheromone, and a exciting pheromone. So it even starts dancing after some time. So you see the wind blowing there, but still we are able to manage it. That's the power of this particular chemistry. Not just small insects, even big animals like even elephants can be, we can modify the behavior. So here you see I have kept an honeybee pheromone in the form of a tablet. So elephants are scared of honeybees. They run away. This came in National Geography. We have demonstrated that honeybee pheromones can modify the behavior of it. They are very scared of honeybees because they sting their ears. So they run away. So that's the power of semi-chemicals. How to tap this and you deploy for crop protection is the story all about our ATGC. So in simple layman words is what we call is an insect family planning tool which we try to create. So what we do is we produce sex pheromones of a female insect and place them in of more than 400 source points, like each source point will be like a chickpea, and this emits 10 times than a virgin female, and the male will never be able to mate with its female partner. So therefore there will be no egg laying, there will be no further generation. So this phenomena is called mating disruption. It is available for 2 or 3 products, but very, very expensive. If you see there, the product, similar product, what is sold in the European market, it's more than 300 pounds. So from 300 pounds to the farmer to use, for them to use in India is what is the transition which we bought. With 26 patent innovations in synthetic biology, producing pheromones in eastern plants, and taking them to the field is what we developed on those lines. So what happens? So farmer need not spray any insecticide. He just have to apply 400 spots per acre and forget about it. The entire season there will be no pest at all because the pest never multiplies. So this is the delivery systems which we use. So material science will play a very critical role in sustainable agriculture. Today the materials which we use are totally fossil fuels. It's all hydrocarbon based. We need to change that. So material science, integrating material science into the R&D is a very, very critical part of it. Collaborations with material science will really change the way we pursue the chemistry in the future, be it agrochemicals, be it agribiologicals or anything. So material science are the key for us to collaborate and be successful. That's where we collaborated with almost 4 national institutes in India: JNCSR, IACS, ISC, and then NCL Pune. So with this, we developed several of the technologies and deployed it for area-wide management. So what is area-wide management? You might have seen locust. There is locust everywhere in the, you can't really do anything. You can't spray or kill all the locusts at a time. So what do? You suppress the population. So I'll tell you four big largest programs which we conduct globally. So I will explain. The first one is the slow the spread program from USDA. So the same glue what I showed you earlier, we fill in the kettles under the flight. You see two buckets. We fill in those kettles, and when they spray like a rain droplets. So each droplet will behave like an artificial female. So what we do is we spray along the borders of Canada and the US, and 1 week before they emerge from the soil. They hibernate in Canada. All the gypsy moth by end of the last season cycle, and when they emerge, when they enter the United States and during the spring, when we 1 week before we spray the pheromone, so all the males will go in one direction, females will go in one direction. There will be no mating, and if forests are protected. Not only forests are protected, but also this gypsy moth is a big menace for public. So people develop rashes because of the larvae which they spray allergens. So this is the world's largest mating disruption program which we are implementing for the 9th year this year. Yeah, before this we were part of the USDA pink bollworm eradication program. You might have seen pink bollworm eradication program, which is a big problem now in India. So we were part of the pink bollworm eradication program when we suppressed the population for 2-3 years. Thereafter we don't need any more intervention to manage that particular pest. The second program is in Argentina for grapes, for vineyards. Again, we do the same program. And the last one is for Australia. Again, this is for vineyards. In India, we do for 4 different pests, major pests: rice yellow stem borer, sugarcane shoot borer. Pink bollworm is the first product after independence. Any company has registered a new molecule. So that's the one, the tube which you saw, that's the first molecule which was launched, and then followed by brinjal foot and shoot borer. So if you look at our horticulture crops and agricultural crops, people spray more than 30-40 insecticide sprays to manage these internal feeders and borers, because there is no chemical molecule which actually can penetrate the plants to manage internal feeders and borers, including fruit flies. So that's the reason why you need to have alternate approaches to manage this kind of pests. So the first 2 products we launched is pink bollworm, brinjal fruit and shoot borer, and third one which is going to launch is for fall armyworm. So this is how we spray. So this is left side is the Canada and right side is the US. This is Lake Superior, the largest lake in the world. So we spray almost 1 lakh acres along the borders between these 2 countries. So when we spray up to 2-3 months, they don't mate, and thereby all your plants are protected. They fly very low because they have to be sprayed as a rain droplets, not as a blanket spray. Not more than 400 spots per acre, hardly 150 grams per acre. That's all it is required for managing the pest for entire season. So this is the first slide, third, fourth slide, which I showed you how I'm modifying the fruit fly. So this is the male annihilation technique which we use, and oviposition deterrents. So combination of oviposition and the similar chemicals will attract and kill. It's called male annihilation technique. So this was deployed in fact in BCKV under a very large program in Malda. So in 15 days we don't see any population at all. So this is how we apply in the crop for cotton. So 3 applications with just 2,000 rupees, farmer is able to manage the pest. Today it's cost of the sprayman. Like chickpea, we apply in the axil of the leaf, and each of these droplet will behave like an artificial female, and males will hover around this. So adults live only for, as you all know, they live for 7 to 8 days. If you confuse them for 7 to 8 days, that's there ends the story. Yeah. So this is what happens when you apply. There will be no population. If you monitor the population, it will be 0. Whereas even if you spray 10 insecticides, you see more than 5,000, 10,000 moths per trap. That's the current situation in this. So this is the first product which was launched. More than 100,000 farmers have adopted. 2 companies are retailing it at the ground level, Indophil and Natco Pharma. So both are selling in the market. This is the third product which we will be launching for Tuta absoluta. This is 4th product for diamondback moth. So what is this? All sustainable. We use only 5 grams chemistry. That's the importance of this particular product. With 5 grams chemistry for 6 months, you are able to manage the pest. So that is all about resilient and regenerative agriculture, what we are talking of. Again, this is for fall armyworm. This is, you can read USAID manual of integrated pest management you will see a complete write-up of 3 different technologies: a tablet delivery system, a glue delivery system, and a spray delivery system. All these 3 are part of the USAID manual for fall armyworm protection. And also before this, for pink bollworm, there is a case study by World Economic Forum, and it also has come by Office of the Prime Minister Scientific Advisor in in Vignan Dhara magazine. For last month edition, it has come about this particular concepts being introduced in India. So this is again another chemical anti-aggregation pheromone which we use for what does anti-aggregation pheromone does. So anti-aggregation pheromone basically communicates that this particular field is damaged, though, so they don't need, the coleopter need not colonize. So we protect 2 national forests in US, the Yosemite and Yellowstone, by providing anti-aggregation pheromone. So what happens is, these beetles communicate that there is this particular field is damaged, they don't need to colonize. That by there be, if you look at our 2 grants which we got from SBA, we showed 100% control for these 2 particular products. This is in Australia, where we protect almond crops. This is Hadley Farms in US, California. We manage carab moth. So these are the pests. Out of $550 billion loss because of insect pests. Today, insecticides all together address only $18 billion. $32 billion is managed by BT technology in maize, corn, and cotton. Rest all $400+ billion insect loss is not at all, we don't have any current solution. Yeah. So because these are all coleopterans, which are internal feeders and borers, absolutely there is no solution. So there is a lot of scope to develop products for against these particular pests. So today we are very proud that India has become first country to out-license to Israel. We have been always hearing that we are in licensing from Israel Technologies. So we are the first company to out-license Israel. 18 products we have out-licensed. So today we are launching our products worldwide. More than 44 products we are launching in more than 50+ countries, with 9 multi-billion-dollar companies coming forward. So these are the many products for many crops. It addresses helicoverpa, legumes, fall armyworm, and then several of the horticulture crops, several of forestry pests. More than 44 products across the world we are launching. So what is the key? That we bought a 300-pound, basically about 30,000 rupees, 2,000 rupees. So it's not that we are making cheap. We are not cheap. We are developed a technology which is affordable. So that's the key difference. So what it is synthetic biology. So if you unravel, the insects produce pheromones in nature. So how they produce? Through a biosynthetic pathway. If you unravel the biosynthetic pathway, so you are able to produce them in yeast or plants. So we transform those genes in yeast and plants, and then we are able to produce. But again, you need another technology. If you produce like any other vaccines or biosimilar, it will be again very, very expensive. So we developed the world's first platform wherein the yeast can produce pheromone with oil in just water as a medium. There is no energy, zero energy. So this is biocatalysis, biotransformation. This is another area of sustainable product development process. So here, if you mix oil and water, in 48 hours, you have your pheromone in place. So that's the key thing. And again, sugars, natural sweetness, there are several of these particular aspects which we are working on. So we are going to replace the entire sugar with natural sweetness, again through synthetic biology and biotechnology. So these are the 3 products which we are using, developing through one of our investments. And now AI really will help in identifying targets, as well as developing a tool for the set target. So we developed our first peptide-based vaccine, which can really reduce your obesity, clean your fatty liver with, make it absolutely clean, and reduce the triglycerides by almost 45% in just 2 shots. So that is where we have demonstrated. This is another animal husbandry program. So these areas broadly we work. I also work in oncology, but today's context is not that. So how innovation drives. So each innovation will drive to a unlocking potential of more than $1 to $2 billion. So if you look at my product portfolio, it will be like $5 billion, more than 30,000 crores we can unlock with if provided you address the needs, the crisis, and you find a solution through biotech intervention. So that's the USP of any innovation when we take it in appropriate way. Yeah. Thank you so much.
Thanks a lot, sir, for such an insightful speech. We will just take 3 minutes to arrange this stage. So please just Dr. Madhumita Mitra Sarkar, Dr. Amit Baran Sarangi, Professor Prabhat Kumar Sarangi, Dr. Shankar Kumar Acharya, Dr. Anshuman Jaina, Dr. Pramod Kumar Raut, Dr. Jo K. Kizakandan, Professor Supriya Patnaik, VC CUTM, Dr. Anita Patra Ma'am, Registrar of CUTM, Dr. Sagar Maitra Sir, Dean of MSSOA, and Dr. Pragya Pani Ma'am, Dean of Management.
Good morning, everyone. Welcome to the plenary session of National Conference on Climate Smart Agriculture, Innovation and Adaptation for Sustainability. In abbreviation, it's CSA-IAS 2025. It's my honor to stand before you today as we gather to address one of the most critical challenges of the era, the intersection of climate change, food security, and sustainable agriculture. We are here with our panelists. Already Shrudipa has talked about them. This session will be chaired by our Honorable Vice Chancellor Professor Supriya Patnaik Ma'am, co-chaired by Professor Anita Patra Ma'am, Registrar Centurion University, Odisha, and Professor Sagar Moitra Sir, Dean M.S. Swaminathan School of Agriculture. The plan is that we'll go for a panel discussion, and before that we'll get some insights about the whole conference from the operational secretaries. This time this conference started to think a bit out of box. What we have planned, instead of centralized system of organizing secretaries, we have went for a decentralized system. For everything we went for separate operational secretaries. Actually, they are the organizing secretaries of each session. So it's the cumulative effort. As we convene here, we acknowledge the staggering statistics that undergone the urgency of our discussions, with 347 paper presented here. And we got the abstract of 384 and presented across 14 themes, and with 402 registered participants, and the conference registration was 387. The scope and the depth of our engagement was the testament of gravity of the issues at, at hand. Climate change and food insecurity stand the monumental obstacles to the global development. The global agri-food ecosystem alone contributes a significant one-third of the emissions, while striving meet the growing food demand of anticipated 9.7 billion people by 2050. Various types of discussions had been carried out in last 3 days. We had a very good posters presentation session where 179 posters have been presented by the participants and the delegates of across the country. Actually, the best persons who can give you the insights about the key takeaways are our operational secretaries. I'll request them one by one, please, theme-wise, come one by one and take 2 minutes to give us the glances of your sessions. What are the major takeaways? What are the major give us the major statistics, and it's your session. It's your time. Uh, I request operational secretaries of Team 1, please come over the dais and have give us some insights about your session.
Very good afternoon to all the participants and the dignitaries present over the stage. I am Dr. L. Sagar from the Department of Agronomy and Agroforestry. I am acting as an operational secretary for the Theme 1, Climate Smart Agriculture and Resilient Farming Practices. So, from the last 2 days, we had a very insightful discussion, both oral as well as poster presentations by number of participants under Theme 1. So today I am going to just give some takeaways that we have actually come up during both oral as well as poster presentations from both keynote speakers as well as the participants present over there. So the first takeaway was, so I will be just summarizing the things. I will be providing the insights from both the sessions that we have undergone from last 2 days. So the first point, research like climate adaptive nutrient strategies and evaluating precision nutrient management highlighted the importance of precision nutrient application to enhance efficiency and sustainability. Tools such as APSIM-based simulations and NDVI monitoring demonstrated the use of technology in optimizing crop performance and resilience. Studies on rice yield influenced by weather variables and intercropping systems emphasized adapting crop production to changing climatic conditions. Resource conservation technologies such as direct seeded rice and zero-till wheat, as highlighted by our keynote speaker, Dr. Nandi Rajareddy sir, are critical for reducing inputs while maintaining productivity. Integration of rice straw incorporation into cropping systems enhanced soil nitrogen dynamics and overall yield of the crop, and strategic management of crop residues and balanced fertilizer use is vital to mitigate the impact of climate change. The studies on nutrient interactions such as sulfur and zinc in cowpea and phosphorus and potassium in black rice indicated the importance of nutrient management for crop growth as well as productivity, and the evaluation of drought tolerant crops such as foxtail millets underscored the need for climate resilient crops and varieties. So with these key takeaways, we have got some potential climate smart agricultural practices and policy recommendations from this particular 2 sessions. So the firstly, I will go on discussing the practices that we have actually found to be potential from these 2 sessions. The first one is adoption of weather-based agro-advisories and precision tools for nutrient application is one of the key to reduce wastage and improve efficiency. Incorporating the residues into fields for better nutrient cycling and soil health instead of open burning is one of the major important strategy to and which can actually act as a climate smart technology. Next, promotion of practices like direct seeded rice, zero tillage and water saving irrigation techniques is another key practice which will actually help us to resilient the climate change. Next, the development of and deployment of drought-tolerant and climate-resilient crop varieties, adaptive weed and pest management strategies to counter the effect of climatic variability is another key. Use of NDVI and other remote sensing tools for real-time monitoring and decision-making in agriculture is another key practice that we have actually identified. So with this, there are some recommended follow-ups from the sessions. So the mainly these follow-ups have been summarized into 5 important points. The first point is dissemination of research findings through farmer workshops, extension services, and digital platforms to promote climate smart techniques, climate smart adaptation, and establish systems to monitor the long-term impact of climate smart agricultural practices on farm productivity, climate resilience, and sustainability. Advocate for the inclusion of CSA practices in national and regional agricultural policies. Identify scalable innovations from studies like EPSIM-based simulations and NDVI-based monitoring for large-scale implementation. Conduct participatory research and on-farm demonstrations to validate and adapt practices for the local conditions. These are, with this few information, I am thanking for the opportunity given. This is the entire sum up of theme 1, so climate smart agriculture and resilient farming practices. Thank you.
Respected dignitaries and participants, thank you for giving me the opportunity. I am an operational secretary of second theme, that is Agriculture 5.0, harnessing AI, IoT and automation for the future farming. In our theme, the keynote speaker was Santosh Babu Baddar. He is the Associate Director Enterprise Security, and he enlightened us about the cyber security and AI in agriculture information system. And we have a 3 oral presentation. One is the advisory services through AI, and second one is on the drone based monitoring system, a sensor driven approach for fish biomass estimation, and it was presented by Ms. Jyotirmayi Behra. And the third presentation was given by agrovoltaic system and its feasibility, and the speaker was Ms. Aditya from CUTM. And these are the 3 oral presentations we had. And in conclusion, our chairperson submitted all the presentation and explained the importance of IoT and sensors in a protected cultivation and in precision farming system. So after completion of our oral presentation, we had a poster presentation in which 5 papers were presented, and evaluator was Dr. Mahesh Hadole, HOD Agriculture Engineering, Vignan University. And the paper post presentation was on review on smart irrigation system, which was highlighted the importance of IoT in modern agriculture irrigation system. And 2 papers were presented on crop breeding and disease management through AI. And also a poster was presented on drone based farming as a important component of agriculture 5.4. And last presentation was on the role of AI in making decision for modern agriculture. And these are the 5 post presentation were there. So this is all for our theme 2. Thank you very much.
Good morning, all of you respected dignitaries. Myself, Dr. Vishnu Prasad Das, working as assistant professor in Centurion University of Technology and Management. I am the operational secretary for the theme 3, that is innovative soil and water conservation techniques for sustainable agriculture. This theme receives around 20 papers, which covers 4 different states: Odisha, West Bengal, Maharashtra, Andhra and Telangana, in which this is exactly one insightful platform for discussing the different approaches and practices in soil water conservation. In this session, the participant discussed different sociological approach, technical approach, and also the advanced methodologies for addressing the challenges in sustainable agriculture. The major topics discussed like sustainable soil water conservation managers among the different tribes of Andhra Pradesh. Another one was there, the factors discriminating the farmers' participation in effective canal irrigation of Karnataka management. These are the social view. Also effect of different organic nutrient management and nitrate leaching and the conservation agriculture approach. The key finding was there, indigenous and traditional practices, they can complement the modern soil and water conservation technique for sustainable agriculture. Innovative materials like jute caddage, it holds significant promise for addressing soil erosion and preventing crop productivity. Scientific insights into nutrient management and irrigation system are crucial for optimizing the resource use and minimizing environmental impact. Conservation agriculture offers a systemic approach to addressing the soil health and climate challenges. The session underscored the importance of different interdisciplinary approaches and stakeholder collaborations in advancing sustainable agricultures. These innovative techniques and research findings presented, they have the potential to inspire policymakers, researchers, and practitioners to adopt and promote effective soil and water conservation strategies. Thank you.
A very good morning to one and all. Myself, Ravuri Sai Prashant, Theme 4 Operations Secretary, Progress in Agriculture Mechanization, Automation and Engineering Solution. We have total oral presentations of 4 and 2 poster presentations. The session started with insightful presentation of Dr. Syed Imran, keynote speaker, about revolutionizing AG mechanization through robotics and AI. He gave a brief idea on precision agriculture, sensors, actuators, programming languages, and simple electronic devices. And then followed by oral presentations. We have different subjects on the design concepts of AI-based maize sheller using fuzzy logic and PLC for grain quality, use of drones in vegetable farming, modern tools and technologies to enhance the fiber quality and yield improvement in jute, and spray drift pattern analysis of different sprayers to enhance the precision spraying. The session concluded with the remarks of session chair Dr. Bhavani Shankar Das, AAE Paralakhemundi. The session chair was also so elated with the participants' interaction ideas, and he also addressed the current trending research topics in the field of mechanization. The key takeaways are different uses of sensors, automation, technology development of self-operated machineries. On the second day, we had poster presentations with 2 presentations evaluated by Dr. Mahesh Hadole from Vignan University. All the evaluators praised the meticulous planning and execution of national conference, highlighting its exceptional organization. Thank you.
A very good morning to all the panelists, delegates, participants in this conference, whoever is present here. So I am the operational secretary for the theme 5, that is session titled Breakthroughs in Post-Harvest Management and Food Processing Technologies. I am Dr. Ruby Pandey. For this session, we had keynote speaker from NIT Raurkela, Dr. Chandrakant Dalbhagat, and a session chair from IIT Kharagpur, Dr. Sujosh Nandi. So under this theme, we had total 7 oral presentations, including the presentation by keynote speaker and session chair, and we had 3 poster presentations by the UG and PG students. Diverse topics were presented, ranging from application of IoT in food technology to common processing methods such as drying. Food processing machine design was also discussed in this session, and shelf life extension of fruits was also talked about in this session. The extraction of bioactive compounds from milk, lactoferrin, that was also discussed, and isolation, characterization and identification of probiotic species bifidobacterium using a RLP fingerprinting with CLPC gene as a molecular marker was also presented in this session. Insights into the development of low-cost eNose device for detection of fruit and vegetable ripening and addressing the iron deficiency across the nation by producing iron-fortified rice kernels was the key highlight of this session. The poster's presentation by students included the topics addressing the plastic waste generation by providing solutions for making biodegradable plastics using food waste, effect of different nutrition media on red lettuce growth using hydroponics was also part of this session. Overall, it was a highly knowledge enriching session for all the participants. I thank the organizing secretary for giving me this opportunity to coordinate this session, and it was a good experience for me. Thank you.
Okay, so good morning, one and all the dignitaries on the dais and off the dais, my dear colleagues and students. So, I am Dr. Subrajyoti Chatterjee, Assistant Professor in the Department of Horticulture and also the Operational Secretary for theme number 6, that is Advances in Sustainable Horticulture. And in total, we have got 27 number of abstracts, and those are covering several states like Telangana, West Bengal, Odisha, Andhra, Rajasthan. So, and those are divided into 11 oral presentations and 16 poster presentations. And for our session, we got three delegates as the keynote speakers: Professor Madhumita Madam, A.B. Sarangi sir, and also Dr. Partho sir, and chairperson Dr. Chandan Karok sir from BCKV. So if I just brief about the key takeaways. So from the keynote I will start with. So from the keynote, basically A.B. Sarangi sir discussed regarding the effects of climate change on spice crops. And as we know, India is the leading producer of spice, but how the spice crop production is getting affected. Sir was talking about this and how we can control that thing. Madam Mitro, she was basically talking about the floricultural crops, and Madam was emphasizing about some underexploited floricultural crops which are having good export potentials, and which that crops can be cultivated at a large scale, and that can give us some very good economic return. And Partho sir was discussing about several kind of key approaches for for maintaining the sustainable horticulture, to approach the sustainable horticulture. And from several oral presentation, basically we have seen the discussions regarding climate resilient horticultural crop production, impact of climate change in horticultural crop production, especially on vegetables, flowers, and fruit crops. And different strategies were also discussed regarding the mitigation. Then several breeding approaches through which we can develop several biotic and abiotic stress resistant varieties. We have discussed about the hydroponics, aeroponics, aquaponics. Basically we are concentrating on 3 or 4 crops on hydroponics. So what are the other crops that can be added in hydroponic system? And also we have seen hydroponics onion production, which is also a new technology which is basically done by BCKV. We are discussing about the urban horticulture, vertical farming, and another very important thing nowadays that is a demand of the hour, that is the introduction of the underexploited orphan crops. It can be orphan vegetables, orphan fruits, orphan flower crops, orphan spice crops, whatever it is, we have to introduce those things. And also regarding value addition and processed products of horticulture. So these are the several takeaways from our session. So thank you very much to the organizational secretary for this particular national conference, for giving us the opportunity to conduct such a good session. Thank you very much. Thanks all. Thank you.
A very good afternoon, everyone. My name is Dr. Nihal R, and it is my honor to present the key takeaways from the oral session for the theme 7, that is crop protection, facets and futuristic approaches. The discussion provided invaluable insights into innovative research and strategies to address the emerging challenges in crop protection. We began the thought-provoking keynote by Dr. T.S.S.K. Patro sir, who showcased the immense potential of the millets as God's own crops for ensuring food, nutritional, and livelihood security. He highlighted the resilience of millets due to their short life cycle, stress tolerance, and C4 photosynthesis. His work included developing of resistant varieties for blast disease in little millets, screening for core germplasm for ragi blast, and promoting millet cultivation through seed hubs in tribal areas. This was followed by the address by the chairperson, Dr. P.K. Sarangi sir, who explored the link between the climate change and pest dynamics. Emphasizing how shifting weather patterns increase pest outbreaks, he called for sustainable pest management practices through integrated approaches and collaboration with farming communities to mitigate the impacts. Other presentation investigated the morphopathological diversity of Rhizoctorius orpathovores in Odisha and Andhra Pradesh, offering insights into their security and impact on major crops. Similarly, the session explored the reproductive behavior of bruchets, shedding light on their host preferences and influence of multiple mating on their population dynamics, helping refining the pest control strategies. The fungal disease management, a study highlighted the importance of optimizing media for native rhizosporic bacteria, showcasing their effectiveness against root rot, blight, damping off, through antifungal metabolite production and induced plant resistance. Additionally, the crop rotation was discussed as a sustainable method for suppressing Sclerotium ralstii with soil suppressiveness varying across agroclimatic zones. The poster presentation was equally enriching, covering diverse topics such as IPM for brinjal shoot and fruit borer, the role of biological control agents in sustainable agriculture, and the use of botanicals and agrochemicals for managing biotic stress in mushroom cultivation. Advances in bioinformatics for breeding, protected cultivation for climate resilience, and development of climate resilient maize varieties were also presented. Mushroom related research highlighted the efficacy of liquid spawn versus grain spawn, substrate selection, and the use of local byproducts for oyster mushroom cultivation. In summary, the session showcased groundbreaking research and practical solutions for sustainable crop protection, paving the way for more resilient and eco-friendly agricultural systems. Let us continue leveraging these innovations to ensure a sustainable and future in the agriculture. Thank you very much.
Respected all the members present here and the audience, this is Dr. Swapnil, the Operational Secretary for Theme 8, which was Plant Breeding, Biotechnology and Crop Improvement. The keynote speakers for our session were Dr. Vijaypal Bhadana and Dr. Rajkumar Joshi. Sir, they gave an in-depth description about the development of climate-resilient variety in rice with phosphorus uptake genes, that is PUP1 gene, and their molecular characterization. An emerging discussion on the genomic assisted breeding in onion was also there in our session. Further, the theme comprised of an impactful presentation on biofortification of millets by Dr. N. Anuradha Madam, Senior Scientist, RARS Vijayanagram. The oral session had very interesting topics like gene expression under chromium and salt stress in onion crop, and how many genes which were responsible for this were identified and their structural characterization. Next presentation gave an valuable insight on the lab-on-chip devices which integrates multiple lab functions on a single chip. There was a discussion on the benefits of real-time monitoring, their challenges and limitation about its usage in the agriculture. This was followed by a presentation on advanced molecular breeding approaches through bacterial wilt resistance in brinjal crop. There was a discussion about the development and validation of PCR-based SNP markers, the gene sequencing in brinjal crop. It was followed by a presentation on genetic variability study in watermelon genotypes, its characterization and evaluation under Odisha conditions. Followed by a presentation on genetic variability, heritability, correlation studies in vegetable cluster bean in northeastern Ghat regions of India. There was a discussion on characterization of different vegetable cluster bean genotypes as well. Further, the poster presentation comprised of many MSc students, almost 29 in number, who showcased their research and review work on the topics related to plant breeding and biotechnology. The topics covered were related to omics technology for crop improvement, breeding for climate resilience, gene editing, that is CRISPR-Cas9, marker-assisted selection, integration of artificial intelligence and machine learning in plant breeding, bioinformatics in plant breeding, and conservation of the plant genetic resources. These presentations highlighted the cutting-edge advancement and innovative approaches shaping the future of agriculture. The student work demonstrated a strong commitment towards the crop improvement program through their research work and study. Thank you.
Good morning, everyone. Esteemed delegates on the dais and off the dais, dear participants. So, I am Dr. Ajay Kumar Prusti. I will be presenting the summary of theme 9, which is food security, sustainable agriculture, approaches of agricultural extension. So, we were honored to have Dr. Shankar sir as our keynote speaker and Dr. Ansuman Jaina as our chairperson for the session. So our oral session opened with compelling keynote speech on entropy, chaos and co-creation by Professor Shankar Kumar Acharya sir, setting the stage for rich discussions. Then key oral presentations included comparative analysis of time series modeling techniques, emphasizing data-driven decision-making in agriculture, innovative irrigation management at village level, and fostering sustainable practices. Presentations also highlighted the role of family farming in sustainable agriculture, then women's contribution to climate smart agriculture. So coming to our poster presentations, our presentations showcased diverse topics like transformative role of ICT in agriculture, integration of ICT in teaching methods, then strategies for enhancing food security, innovative extension approaches. So the session were concluded with engaging question answer sessions, and together these sessions underscored the importance of combining technology, policy and community driven approaches to address challenges in agriculture and food security. Thank you.
Good afternoon, everyone, delegates and panel members, and all the participants and dear colleagues. I, Dr. Pratyush, along with Mr. Bhadram Kalyan Chakravarti, hereby represent the theme 10 as operational secretaries. The theme was titled as Advances in Phytopharmaceuticals and Natural Product Development. So this particular theme had 3 keynote address and 1 session chair. The keynote address was first given by Dr. KVM Ramarao, the Vice President, NATCO Research, Hyderabad, India. And then it was followed by another keynote research by Dr. Tejo Krishna Kure. She was the Senior Research Associate at Hayati Life Sciences, Hyderabad. The third keynote was given by Dr. Mamuni Das, Scientist D, BRIC Institute of Life Sciences, Bhubaneswar. The session chair was Dr. Sushant Kumar Panda, who is the principal of Royal College of Pharmacy and Healthcare Sciences, Barampur. So the KVM Narayan Rao discussed about the importance of AI in drug discovery and analytical method development with special emphasis on phytochemical analysis. Dr. Tejo Krishna Kure presented and discussed the importance of Ayurvedic formulations in the current healthcare scenario. She also underlined the use of nutraceuticals in Ayurvedic perspective. Dr. Mamuni Das elaborated on the role of nucleic acids in managing pests in agriculture by means of RNA interference. She highlighted the ethical considerations and the cost factor that needs to be further researched upon. Dr. S.K. Panda enlightened us with the regulatory aspects and also globalizing Indian system of medicine. He has also highlighted certain points regarding the lacuna behind Ayurveda and the need to overcome them so as to make the Ayurvedic science globally accepted. A total of 25 abstracts were received for this particular theme, out of which 13 were selected for poster presentation and 12 were oral presentation. The poster presentations were focused on various multidisciplinary topics such as impurity profiling in herbal formulations, importance of phytochemical constituents in different medicinal plants, role of green synthesized nanoparticles, ecDNA and AI in cancer therapy. The oral presentations focused on vital topics like role of plant extracts as medicinal and herbicidal formulations, studies related to in vivo studies, ADMET analysis along with mathematical modeling, immunochromatographic and systems biology approaches were also certain key topics under the focus. Thank you very much.
Good morning, one and all. Myself, Dr. B. Divyashri, and I am the Operational Secretary for Theme 11, Innovations in Animal Health, Disease Control and Veterinary Practices. Here, Dr. G. Taru Sharma delivered an in-depth presentation on the One Health concept, focusing on the emerging diseases and advances in the vaccine development. Dr. Pramod Kumar Raut shared insights on smart agriculture farming for sustainable production, exploring various innovative approaches in modern farming practices. Insights and contributions. 20 presentations were delivered out of 20 submitted abstracts covering highly innovative, impactful topics. Highlighted topics include maggot therapy, a novel economical approach that could revolutionize veterinary medicine with affordable and effective treatments. Assisted reproductive technology. This emerging field emphasizes identifying endocrine markers to enhance reproduction, production, and success in animals. Climate resilient microbes. Research into microbes and addresses the challenges posed by the global warming and shed lights on emerging animal diseases. Local breed conservation, vaccine production, ethno-veterinary medicine, cost-effective treatments with no side effects, showing a promising innovation in animal disease management. Outcomes and resolutions. The session underscored the importance of integrating advanced technologies like PCR and ART into veterinary practices to improve outcomes. Discussions emphasized the need for continued research in climate resilient animal health solutions and innovative therapies. Economical feeding patterns and animal age related metamorphic studies were identified as key areas for further exploration. Actionable steps. Promote the application of maggot therapy, ethno-veterinary medicine, and veterinary practice. Encourage research on climate resilient microbes to mitigate the effects of global warming on animal health. Develop practical approaches for endocrine markers to enhance assisted reproductive technologies. The session was enriched by the expertise of keynote speakers Dr. G. Taru Sharma and Dr. Pramod Kumar Raut. Thanks to all the contributors for their valuable presentations which significantly advanced the discussion on innovations in veterinary sciences. Thank you so much.
Good morning to one and all. Myself Harshvardhan, Operations Secretary for Theme 13, Integrating Tribal Development with Agriculture Sustainability. Here we have the keynote speaker, Dr. K. Ishwarappa sir, Assistant Professor, Department of Tribal Studies, Indira Gandhi National Tribal University, and Chairperson as Dr. Kautsav Mazumdar sir, Assistant Professor, Rural Development, Ramakrishna Mission, Vivekananda Educational Research Institute. Here we have got 10 abstracts from 5 states. These mainly we got the abstracts on the Chenchu tribes, Toto community of Alipurduar district, West Bengal. The key takeaways are transformations of tribal communities in agriculture, highlighting both the challenges they face and the innovative solutions being implemented for the socio-economic upliftment, and challenges and transformative opportunities faced by the tribal communities in various regions, showing how socio-economic dynamics, modern interventions and traditional practices interact to shape their lives. With this, I conclude this. Thank you for the opportunity.
Good afternoon to all the dignitaries, my dear faculty and student friends. I am Dr. Akkamahadevi Nayak, Operational Secretary for Theme 14, Agribusiness Strategies for Sustainable Development. For the session, the keynote speaker was Mr. Pratik Panda, DDM NABARD, Chairperson Dr. Sujata Madam, Department of Agriculture Economics, and the rapporteur is Dr. Chitrasena Padi, Department of Agriculture Extension. So in this session, we had 4 oral and 10 poster presentation, and the eye-catching topics are like evaluating cultivation and marketing efficiency of mango in Gajapati district of Odisha, income and wealth inequality in India, the case for tax injustice, trends in cashew cultivation and perception of farmers in Srikakulam district of Andhra Pradesh, sustainable rural economic growth through protected cultivation technologies, and integration of digital technology in agribusiness operation in rural mandis, government policies in agribusiness management for tribal farmers, youth inclusion in agribusiness opportunities and challenges, and horti-tourism and approach to enhance farmers' income. And the key takeaways from the session is adoption of climate resilient crop varieties, livelihood diversification, easy access of capital and financing, rural and urban linkage, supply chain innovation, and e-marketing to make easy transaction among buyers and sellers. So I thank Centurion and organizers for giving me an opportunity to part of this mega event. Thank you so much.
Thank you everyone. I think you got the insight of the whole discussion. So we'll be starting the panel discussion. During this whole study, actually, I'll request Professor Pragya Pani ma'am to note down every discussion. The plan is that our chairs and co-chairs, they, they will give us the final way forwards. Before that, today we have with us Dr. Markandeya sir. Sir, we are having a question. Whenever we used to talk, uh, microphones are there? Microphones. So it's actually whenever there is a conference, it could be academic, we used to find out one thing that people are having two types of narratives regarding regarding climate resilient practices of agriculture. I'm citing one example. Uh, During 80s, 90s, there was an infamous case of starvation and hunger. And it is, if we'll cite the famous book of Magsaysay Arduino, Peace on Earth. Everyone loves a good drought. You'll find that it was a mistake in point of view of us. What he has written, because of artificial insemination, the next generation of the cows which have been produced, they were not enough capable to produce that amount of milks. So there are so many narratives are there regarding Betty Cotton, Betty Brinjals. So we want to get your take, your standpoint here regarding these controversies.
Yeah, I don't think these controversies are really very well studied globally. If you look at Brazil, the livestock population is so high, and everything is BT there. The corn, the soybean, and of course, if you look at all the soya products or soya oil, what we consume in India is derived from BT soybean. Yeah. So it has already been exposed to such a level where there is no other debate on this particular safety aspect of these two proteins. More than today, 140 million hectares has been grown in 2 seasons. So technically, we are talking about a produce of 300 million hectares. I mean, that is at the peak. So I don't think there is any controversy surrounding any of these studies. They are not peer reviewed. Yeah. Taking example of non-peer reviewed without any scientific data, it will be always a bias. Yeah. Yeah.
Thank you, sir. I'll go to Professor. Hello, I'll go to Professor Gautam Saha, former Vice Chancellor BCKV. Sir, actually, we are talking about a narrative. You just check out one thing. One lady was there. She just passed away some days back, 2 months back. She is Padma Shri Kamala Pujari. She was hailing from Malkangiri district. She probably she documented, actually she collected, stored and propagated 150 types of indigenous paddy varieties. Okay, and people recognized her, and along with these, M.S. Swaminathan Research Foundation, they supported her. This kind of several stories are there. But do you think so-called seed bank movement of of various NGOs and societies will be able to feed the whole nation? As because during 1959 we faced severe famine. Thereafter we had to move for green revolution. But we are talking parallelly, we are having certain, numbers. People are showing we should go for this kind of seed banks. Even they are citing the example of Sundarban Aila case. After that, only indigenous paddy varieties sustains. This kind of examples are coming, papers are coming. How much reliable these theories are?
Actually, this is a part of climate smart agriculture for conservation, for collection and preservation of traditional varieties. Practically, after Green Revolution, we forget all the traditional approaches, traditional varieties. After 60s, after Green Revolution, we have high yielding varieties, excessive fertilizer use, everything was there. But due to this excessive fertilizer and high yielding varieties, the most of the traditional varieties lost. So in West Bengal and eastern part of our country, through self-help group, they are collecting the traditional varieties. They are very much resistant to drought, pest incidents and others. So from the central government side, this is another approach. Collect different traditional varieties and develop some seed bank and propagate and multiply this using some recent technological intervention.
Like, sir, can you please
So in
put
this
some?
way, we can proceed to in this line of climate smart agriculture. This is another important approach.
Thank you, sir. I'll go to Professor Shankar Kumar Acharya, Professor, Department of Agricultural Extension, Faculty of Agriculture, former Dean PG Studies, former Director DEE, Vidhan Chandra Krishi Vishwavidyalaya. Sir, I'm having a serious question. It's an allegation for the extension professionals, for the extension educationists. So whether we are talking about innovators, laggards, don't you think we are the laggards? We the people who are so-called extensionists, why I'm telling you, sir. Sir, you just check out in our books and in our presentations, in our practicals, still we are making posters, banners in hand, this kind of things, sir, they are. We have, we overcome the generation of Photoshop. Now people are using Canva and AI. Still you are using those paper made materials. No one is using it. Second is that whether our textbooks, what says, whether it is practically, fitted or not, sir. What is your takeaway regarding, as big as extension people used to talk about so many things, is it possible to, to disseminate climate resilient technologies to the
Okay, I'm really feeling honored to be here, and Vice Chancellor Madam and all these dignitaries. Your question has got two parts. One is whether this classical extension is still relevant,
yes,
the way we are moving ahead, what are the options? And second part is that by using this, the advanced and edited extension versions, we can deal with the climate resilience aspect and issues. I do agree with you that if any discipline in Indian agriculture needs a paradigm shift, 1, 2, 3, first there should be a paradigm shift in extension science. And I had for the last 36 years, 117 books I have authored. You can find it in the Google search. Most of the books and researches I am hovering around the alternative, the paradigm shift in extension science. First one is that there is no kind of rhetoric transfer of technology. If any ICR persons are there, this is my submission to them. We need to have a change in our policy. What to transfer? We want transformation. These classical cliches of transfer of technology, TOT, should be in the transfer for transformation. If there is no transformation, what is the use of transferring these things? Second thing is that the adoption biases. Every KVK should have a rejection data. Perhaps I am the solitary researcher in this continent, subcontinent, who went on, and my lab, who went on working on the rejection paradigm. If you know why the farmers are rejecting, perhaps you are the wisest person to know why should they adopt it. That's why I applied, that redox process, oxidation and reduction. In the extension science, it is called resorption, already well known across India and beyond. Third is that, that one is important thing is that why the farmers should not get monthly income. This is my question. I have thrown it to JNU, to Delhi University, to elsewhere in the world. Why the Indian farmers don't get a monthly income? Everything he has to pay monthly. Electricity bill, his health, his family education, etc., etc. But only he has to wait for 6 months for his income. And it is uncertain. So we need to have a model wherein every farmer should be ensured with a monthly income, because we are taking food every hour, breakfast to dinner and supper, but the farmers have to wait for 6 months to have their price, to have their price for their produces. Even it is uncertain. Another important thing yesterday I was working that another very theoretical exercises, theoretical frameworking for extensions are very, very poor. The same repetitive work, KVK, impact and technology gap, I'm really tired of it. So I have started applying physics into the extension science model. Social physics was a subject, August County, you know that, 1853. So 2025 years scare of mathematics and physics in applying in extension. Why? So next thing is that the last thing would be that first you know why the farmers are unhappy. First you know why the farmers are passing through and driven into the domain of extreme uncertainty. Income is uncertain, weather is uncertain, technology is uncertain.
Sir, what's about technology transfer and those who
No,
are...
no, no transfer, transformation.
Transformation, okay.
You work on
Sir, we are
transformation.
talking about some subjective jargons. Sir, what is my opinion? Sir, it's a clear question whether is it possible for our extension workers or extension professionals to disseminate drone technologies or IoTs within a couple of years? Is it possible, whether we are capable enough?
Dr. Dev, my suggestion is that, that this is the process. I am focusing on the method and theoretical input. What you are going to do? Same problem will be there. You are applying drone, you are ensuring yield, but there is no market around. So you know that you have to go for, theoretically of course, empirically, not theoretically, to estimate what is the amount of uncertainty. Once you know that this is the volume of uncertainty, perhaps you will be the wisest and most pragmatic person to ensure their certainty. First, ensure certainty for the farmers. Then you transfer and transformation, all these things. Last submission is that I don't bother about global warming. I am really concerned about social warming. Tons of bombs are thrown and destroyed. The same leaders meeting on a global summit and thinking seriously how to quell global warming. It is so funny. First, social warming to be controlled, the policy to be there. Why the leaders are throwing bomb? Why the leaders are marketing the pernicious pesticidal product? First, tame the mindset of our global leaders, and a new kind of theoretical framework would be there. I focus on social warming and less on global warming.
Pardon me, sir. Sir, we want to get a quick take away from
Yes,
you,
yes,
sir.
thank you.
Yes, sir. Yes, sir.
I can add.
Yes, sir. We need
just one point I will add.
Yes.
Don't blame our technologies or extension specialists.
I'm not blaming.
No, I am telling why. Because I will give the data. What is the present agricultural production scenario? Previously, if you take the data of a vulnerable year and a very normal climatic year. So whenever before 10 years data, if you see, there was a difference in food production by 30% in a vulnerable year and a normal year. But if you check the last 5 years data, our food grain production hardly matters by dwindling at 10%, not less than that. So why? How is it? It is due to technological application in agricultural science. Or we have the technology and we are disseminating it, and even if extension failures, our farmers are not that, they are very wise, they are very permissible, they are adapting the technology, and by which now our food grain production in a vulnerable year and a normal year hardly varies within a 10% range.
Okay.
So that shows our strength.
Obviously, sir. Sir, we wanted to take
one last submission. That is, I'm not focusing on that. That is the failure of the technology. I'm focusing on the interface between technology and human need. That is the problem. And second is that transformatics, a new science are coming up. We are trying to have it. Not transfer. Transformatics will be the pathway. How best we can have a transformation of the human behavior to a positive direction so that he can feel secure. That is the security is the questions.
Just madam is there. Just can you just tell, excuse me, Just can you just tell what should be the transformative journey here? Can you discuss for 2 minutes? Can I tell?
Sure.
So I think if you see I must give a very good congratulations and appreciate the effort of this university at this location particularly. And you can see whatever our different presenters, your secretaries present. So the gamut of different disciplines of specific subjects covered, tribal development to agribusiness development. You can see here regenerative agriculture to your all different aspects. Whatever we have covered. So what does it signify? Now I can say this is the best food production or food system transformation journey for this region by this university. I think you must know that we have now a clarion call by our Prime Minister that is because it's Bharat by 2047. So 2024 is the best year, so you are not starting. So this think tank or insight, whatever I got for this university, Centurion University, that is now the stepping stone by which we should start a food system transformation journey. So for the next 25 years, how you can plan for this region and for this country, for this nation, and not only for this region, not this same similar climatic condition, tribal all over the world, we can think of this. So this university should plan in that way. Just a minute, sir. So this is the position because we have to take what is the different aspect of because this university has a plus point. What I have seen, you have now adopted all modern technology, IoT-based technology. That is the application in the field. So you are capturing data from all aspects, be it agriculture crop production, be it horticulture production, be it fishery, livestock production, and these are the aspects you are capturing the data. So I don't know what is your database and how you are storing data and capturing data after this, how you are handling this data. That is another aspect. And this data handling, as we are discussing in the how artificial intelligence application, and you have already discussion. So now, basing on this data, now you can develop different foundation model, which will give age your resource use, you develop the different sustainable farming practices, and give you an idea about the robust supply chain management. So this way, this university can plan developing the artificial intelligence foundation model by which we can do wonders in the, because that will give an edge for managing our resources and developing robust farming practices. That's all.
Thank you, sir, for the insights, and thank you, sir. Sir, we wanted to talk to Pramod, sir. Sir, what actually what was the discussion? Sir was talking about a situation, and also we wanted to get from Markandeya sir and other jury members, Joe sir. Sir, actually, what is the at the beginning we are talking about some narratives, sir. You don't find, sir, what Professor Acharya sir was talking about. Sir was talking about global leaders are doing these things, and these pesticide companies are the, you got it, it's a corporate trap and those things. But without pesticide, without chemicals, we are talking about climate resilient agriculture. But I'm talking about one thing, without it, is it possible to feed the whole nation? Is it possible, sir?
Thank you, sir. It's my domain.
Just asking, sir.
Yes. I started this session yesterday by saying, हमको मिटा सके ये जमाने में दम नहीं, हमको मिटा सके ये जमाने में दम नहीं, जमाना खुद हमसे है, हम जमाने से नहीं. I started by saying that,
sir.
And I repeat the same because I belong to the plant protection group where कीड़े मकोड़े बोलते हैं, हमको मिटा सके ये जमाने में दम नहीं. You can't kill them. You can't wipe them. America tried with tunnel bombs to kill cockroaches, failed. So, from pest control, we came IPM, Integrated Pest Management, what is called live, let live. खुद भी बचेंगे, उनको बचने भी देंगे. Now regarding pesticides, what you were telling, can we do out pesticide? For the entire knowledge of the house, yesterday also I said the example, fruit and shoot borer of brinjal. It's a monophagous pest, killing pests throughout the world, and it's a pest of concern. In Odisha, over 2 to 3 years under World Bank project we worked, sir. We only applied in soil neem oil cake. We used this 7 days regular clipping, nibbling of the affected shoots, followed by application of 7 days interval neem oil, use of pheromones and all that. Totally, horrible. Loss was there. It was 10% loss. Suppose a farmer is taking in 1 quintal 10 kg is lost. Can that 10 kg not be utilized in his own house? Does he have to sell that 90 kg and is he not satisfied? It is a question now that we started with Sujalang, Supalang, Malayaja Sitalang, Sasya Samalang, Mataram. But today, no Sujala because of pesticide, no Malayaja Sitala. Everything has changed. The green revolution has changed into greed revolution for me.
Sir,
it's a fact. It's
sir,
a fact. Because we have been
counter
churning,
narratives are
churning,
there.
churning.
We wanted to get some. We wanted to get some counter answer from Markandeya, sir. Sir, please answer, sir.
I have to leave.
Sir, just a minute, sir.
Yeah. So without, I think, giving away the current plant protection tools is not a way. How we can transform them to sustainable solutions is where is important. IPM plays an important role. As I very critically mentioned, material science will play a very critical role in minimizing the chemistry. So the moment you minimize the chemistry with integrated pest management, the ETLs will not cross, and that's where we need to work on. Yeah.
And also what we were talking, another aspect now we are lacking that what sir told, maybe traditional knowledge had. You can analyze from soil microbe to human gut microbe. There is a great journey which we have not yet discovered. First go from soil microbe to that what are the produce there and who is the consumer, we are the consumer, and how our gut microbe is there and what we are observing and what is the manifestation of our health and other aspect, our productivity. So ultimately think of that aspect need to be done. There is a lot of research, so we can think from the whole, as sir told, so physics too, because it is a total production system. You can see, as I told sir, we cannot think in isolation now. Agricultural production system, take it is a be a livestock production system, now it is a energy efficient. How it may be energy efficient? It is law of thermodynamics. Not only pesticide, not only fertilizer, not only anything can do. You take the mass balance concept, apply the law of thermodynamics. What is how to calculate all the energy in terms of input and out of all energy out of output. So it is all about the energy efficient production system. Now you have to think of in holistically. That is the thing, and that is the approach.
Sir, in between we are taking 2 minutes break. Break is for, we are going to inaugurate or launch formally Professor Shankaracharya sir's book on chaos and uncertainty by our Vice Chancellor, ma'am.
Hello. It's our immense pleasure that Professor Shankaracharya is with us. And he so far published 117 books. And this book is the 117th book to be officially released by our Honorable Vice Chancellor, Madam.
I'm really sorry I have to take a leave because I have to catch the flight from Bhubaneswar airport. Our flight has been cancelled from Hijack. I'm really feeling tempted to be here more and to interact with the students and very bright and belligerent. I am thanking you and expressing my gratitude to Centurion University. I'm really very much impressed to see that main focus is capacity building for this university, and huge campus, Sylvine campus, and the discipline, the kind of hospitality we are having, it's simply amazing. Second, I'm taking, this is my take home material, that take home impression. I'm really impressed. And second thing is that, yes, all the panelists was rightly discussing that it is not the time to go totally organic. Then we don't want another Sri Lanka, or we don't want another Silent Spring. We have to go in between. So conservation agriculture might have been maybe one of the important solution to it. And second thing is that we can show the luxury of losing 15 to 20 ton topsoil per hectare per year. We don't show the luxury of losing our groundwater, which was 5,350 cubic meter during 1950. Now it is slashed down to 1,600 cubic meter per capita. It is really alarming. And save water, save soil, otherwise future generation won't survive, not to speak of only our survival and extinction. So that is how it is. We are in a crossroad, but I think this panel discussion will rightly highlight on what is the landing ground, where we should land. No more transfer, more on transformation. No more on just classical repetitions and cliches of jargons and technologies. We want to have a journey and voyage into the very complex mind, complex nature for a simplest solution. So complex problem, but we want the simplest solution. Thank you, and I have to take leave. That's why I am taking a very good memory.
Thank you, sir. We are supposed to close this session. Before we close this session, we wanted to get some way forwards from our chairperson, Vice Chancellor ma'am. Ma'am, way forward. And yes, what to do. Actually, we had several school of thoughts here during this 3 days conference, and several types of things were there. We tried to make an ecosystem of different types of schools of thoughts. So this is.
So thank you, Atanu. What do I say in front of all the dignitaries here? They are the experts. I have very little to say actually, because I think you have also spelled out some of the things which need to be understood and taken forward. But being a social scientist, I thought I need to say something. And I said that, when we were studying social sciences in school, one of the things we often heard was the biggest defense of democracy was diversity. That diversity, and one of the reasons why a lot of people attribute why our independence was so successful was because there were people who were writing in local languages. So that was a kind of levels of diversity which kind of helped the democracy remain what it is. And just before this, I attended a session on AI, and now I'm attending this, and I somehow feel that when we are looking at a lot of these sciences, we are moving more and more towards homogenization rather than diversity. And I think, to me, that is a matter of fear, and I think that is something that all of you people need to consider here, the young scientists, budding scientists. I know you mentioned, sir, that it has to be for local specific, and that is a kind of thing which I also think is what is required. But it always worries me when I hear the kind of presentations which are done, especially by people who are great followers of AI. I don't know why, but it just irks me a little. Having said that, I think, there is also, we had these 14 themes, and I think there is a lot of overlap between those themes. And I think people need to look at those crossings or those boundaries, where they interlap and what do we need overlap and what do we need to take into consideration. So I think whether you're looking at tribal development, crop productivity increase, whatever it is, you can see the overlaps, and I think it's important that we make note of that. and we actually address or we take those things into consideration, because some of the things when I was looking at the poster presentations yesterday, I was highlighting, I attended a few sessions. There also I said we need to understand what particular, we use terms very easily without understanding what actually they mean on the ground. And I think the young scientists need to take care of that. Even things like family farming, that was one of the things I said, what do you understand by family? You know, today, family means so many different things. So unless you understand those kinds of things, I think somewhere you're missing the point, you're missing the boat. So I think these are some of the things that I'd just like to say, because I'm not an agriculture scientist, so I can't really comment on the agricultural aspects, and I think the experts have done it. So thank you one and all for this wonderful deliberations over the past 3 days, and for the very active participation from all of you. It has been a great event. I've attended quite a few in Centurion, not all of them because I just can't, but this is one of the very best ones, organized quite well, and we have got some of the best people attending it. So thank you so much, all of you.